section provides a brief introduction to select methods of making SQL code computationally more efficient. This brief presentation was organized by Dr. Lemmy and narrated by Samantha Tone. ER diagrams describe the entities that should be included in the database as tables and the relationship among these entities. Here we see two entities, one describing the patient and the other street addresses. The relationship between these two entities is described by another table called relationship. This table indicates if the address is current or old. Relational databases are made of tables. Each table defines either a schema for an entity or a relationship. The rows in the table are relational instances. A column in the table represents entity attributes or table fields. The cardinality of the table refers to the number of the rows in the table. The degree of the table refers to the number of columns in the table. Here we have a table with cardinality 3 and degree 5, meaning we have 3 rows of data and 5 columns of fields. To map an ER diagram to the database, one builds a table for each entity. If necessary, builds a table for relationships among two entities, makes a column in the table for each attribute in the entity, sets a primary key in the table, and cluster-related foreign keys. Combination of primary and foreign keys are used to implement relationships. Here, employee entity is mapped to a table with 3 fields: employee ID, which is a primary key, name, which is an attribute of the employee, and now a field in the table, and address, which is also an attribute of the employee, and now another field in the table. No two distinct records in a table can have the same values as the primary key. For example, a patient record number identifies one record in a patient table. Another example, G number identifies one student in GMW Patriot Web System. Foreign key is used to identify records in other tables following relations. Foreign key in one table always corresponds to PK in another table. Using common identifiers in both entities creates the relationship. Here, the primary key in the employee table is a foreign key in the security table. Note that types of primary and foreign keys must be identical. You cannot have patient ID once as a numeric and once as a text field. A key does not need to be defined as a single field. For example, patient name plus date of birth can be used as a key, assuming it uniquely identifies patients. Patient ID plus address type can be a primary key for the address. One-to-one relationships are rare and are used in specific situations, such as to avoid missing data, to model hierarchies, for privacy security reason, or to break very large tables if some fields are rarely accessed at the same time. One-to-many relationships are the most important and the most frequent type of relationship in relational databases. They are used to represent all types of relationships in relational databases. When modeling one-to-many relationships, use foreign key in many to refer to record in one. Examples include patient address. Primary key is the patient's ID. Is used several times as foreign key in address table to indicate multiple addresses for the patient. Here is an example of one patient having many addresses. Foreign key in address points to primary key in patient. These two tables are related to each other because the foreign key in the second table points to the first table's primary key. Now for many-to-many relationships. Sometimes we have entities that have many-to-many relationships. In this design, patients can have many physicians and physicians can have many patients. It is not possible to indicate the many-to-many relationship with just foreign key in either table. The solution is to have a relationship table. It indicates the nature of the relationship in connecting many-to-many entities. Here, the visit table is the linking table between physicians and patients. In this design, patients can have many physicians and physicians can have many patients, and the nature and number of each can be discovered in the visit table. The linking table has two foreign keys. These foreign keys point to two different entities. Neither one of the foreign keys are unique in the linking table. Let us look at an example. This group has several clinics. Each clinic employs a number of healthcare providers. The group serves a number of patients in the area. The database to be constructed will serve the information needs of practice group management as well as providers and patients. We have three entities: patient, provider, and clinic. The attributes of each of these three entities are listed as fields within the three tables. Patient table has ID, patient name, date of birth, social security number, and insurance policy. The provider table has ID, provider name, date of birth, and employee ID. The clinic has clinic ID, clinic name, address, and phone. We also need a relational table or an association table, here called encounter. It has an ID, date, and diagnosis code. To make this scheme work, we need to also introduce various relationships among these tables by introducing foreign keys. The clinic ID is added as a foreign key to the patient and provider ID, as these are one-to-many relationships and do not require additional association tables. The relationship between patients and providers is many-to-many and requires an additional association table, now called encounter table. We introduce both the patient and provider ID as foreign keys in the encounter table. Primary and foreign keys indicate relationship among tables.